Also continuation, their clear extreme position, acceleration, mean position and extreme position acceleration applications, and time period and equation of simple harmonic motion also step by step I'm going to explain. Hello my dear students, today topic is reference circle. Horizontal displacement when the particle is moving on the circumference of the circle in anti-clockwise direction, its velocity and also acceleration applications, mean position and extreme position, velocity and acceleration also I am going to explain. And previous video is same reference circle but vertical displacement like this. Here the particle is moving in anti-clockwise direction, but the particle is moving from mean position to extreme position, extreme position to mean position, and mean position to second extreme position. Okay, so this is vertical displacement, and corresponding displacement, velocity, acceleration, maximum velocity, maximum acceleration applications also completed. This video link I will provide in the description. Now I am going to explain detailedly with clear explanation. Please do like and subscribe our channel Nature of Physics, reference circle, horizontal displacement. Okay student, now a particle P is moving on the circumference of the circle of radius A. A is the radius. With uniform angular speed omega. Omega is the uniform angular speed in anti-clockwise direction during the time t. The projection M, this is M projection of a position vector particle on the x-axis. This is the x-axis. Cover a displacement is x. See there, the displacement from mean position to the M, x is the displacement. Okay, see student, clearly given diagram. This is taken as extreme position. The particle is moving in anti-clockwise direction. It is moving from x to y position, pink color represented. Here also amplitude maximum at the extreme position and reach this position. So here time taken is t divided by 4 and phase is equal to pi divided by 90 degrees. Okay, and next the particle is moving from y position to the minus x. See student, here also green color represented. See, green color represented. So when the particle is moving on the circumference of the circle, it is doing simple harmonic motion on the diameter x dash, that is x and minus x student. Okay, and here time is equal to t divided by 2, phase is equal to pi. Okay, half circle pi. Okay, half time taken t by 2. Next, red color clearly represented from minus x to minus y. See there represented. So first one pink color, 1 arrow, next to 2 arrows, next to 3 arrows, third one is 4 arrows clearly represented. See there, here time is equal to 3t by 4 and pi by 2 plus pi is 3 pi by 2. Okay, and here the particle is moving from this minus y to x, so that is pi, and total time taken is t. Total phase is 2 pi. Okay student, so like this, when the particle is moving on the circumference of this circle, it is doing simple harmonic motion on x minus x diameter. Okay, and corresponding displacement phase diagram also given. On the x-axis is time and on the y-axis is displacement, x is represented. Okay, so this is the positive amplitude, this is the negative amplitude, phase and time period also according to the explanation clearly represented. Okay student, and here simple harmonic motion S.H.M. The acceleration of the particle is directly proportional to the minus x. A body is said to be to and fro along the straight line about the mean position such that at any point its acceleration is directly proportional to the displacement in magnitude and opposite in direction is called simple harmonic motion. Okay student, theta is the angular displacement from position x to the p position, making an angle theta represented. Okay, so that there is a particle moving with an angular velocity omega is equal theta by t. Rate of change of angular displacement is called angular velocity. So cross multiplication, I got theta is equal to omega t. Okay student, and next I'm going to find the horizontal displacement and applications, and also velocity, applications, mean position and extreme position, and so derivation I'm going to start there. So displacement for this triangle O, this is center represented O P M. From this cos theta, which is equal to adjacent side is x divided by hypotenuse is a. Okay, and from this equation x is equal to a cos theta, and theta value replaced by omega t, so that displacement x, which is equal to a cos omega t, this is written as equation number 1. Okay, and applications, that is mean position and extreme positions. Okay, so mean position x is equal to 0, so that the value is replaced there, we will get that value. So here x is equal 0 replace in equation number 1, so that 0, which is equal to a cos omega t, so that 0 by anything is 0, cos omega t is equal to 0 getting, that's why theta is equal to omega t, which is equal to 90 degrees, so that mean position here theta is equal to 90 degrees and x is equal to 0. So linear displacement 0 and angular displacement theta is equal to omega t is equal to 90 degrees. Okay student, and then also next I am going to explain about the extreme position. Extreme position condition is x is equal to plus or minus a. Okay student, and the value is replacing now, that is equation number 1, so that a is equal to a cos omega t. Okay, a cancel, cos omega t, which is equal to 1, so omega t, which is equal to 0 degrees, that is equal to theta. See there, if you take theta is equal to minus 180 when x is equal to minus a, so that value is minus a, which is equal to a cos omega t. A get cancel, so that minus 1 is equal cos omega t, and omega t, which is equal to 180 degrees. See student, like this we are getting extreme position, linear displacement x is equal to plus or minus a, and extreme position angular displacement theta is equal 0 degrees and theta is equal to 180 degrees. Remember theta is equal to omega t students. Okay, and continuation, next step I am going to explain the velocity equation. Velocity v, which is equal to dx divided by dt. Rate of change of displacement is called velocity, so that velocity v, which is equal to d by dt of equation 1 is replacing, so that a cos omega t. See student, x value replacing, x is equal to a cos omega t is equation number 1. Okay, so in this equation velocity v, which is equal to a common, differentiation of cos omega t become minus sin omega t, minus sin omega t, and omega is common because of we are doing differentiation with respect to time, there is a omega t, that's why omega is common. So velocity equation v, which is equal to minus a omega sin omega t, this is I can write as equation number 2a, students. Okay, 2a represent velocity is equal minus a omega sine omega t. So rate of change of displacement is called velocity, clearly written everything. So that in this velocity, second equation I am going to explain. So second equation for the velocity v, that is v which is equal to minus a omega root over 1 minus cos square omega t. Okay, so that sine omega t is equal to root over 1 minus cos square omega t. In this, from equation 1, so from equation 1, that is x divided by, this is x divided by a, which is equal to cos omega t. Okay, and replacing in this equation, we are going to get velocity v which is equal to minus a omega root over 1 minus, so here cos omega t is x by a, so that x square divided by a square, and continuation taken LCM, v which is equal to minus a omega root over a square minus x square divided by root over a square. See student, here a square root of get cancel, and a also numerator and denominator is get cancel. So velocity second equation v which is equal to minus omega root over a square minus x square. This is equation number 2b, student. Clear explanation about the velocity is completed. Then cases are there, that is mean position and also extreme position. So that I am going to write about the mean position. Mean position conditions clearly given, x is equal to 0 and theta is equal to omega t which is equal to 90 degrees. See student, and the values are replacing now, that is equal to first linear equation, that is equation number 2b. So velocity v which is equal to minus omega root over a square minus x is equal to 0 square. So that square root of get cancel for a, so that v is equal to minus a omega. I got here velocity is equal to maximum which is equal to minus a omega. Okay, and also theta with respect to equation 2a using, so there also we will get the same value. See student, v which is equal to minus a omega sine omega t, that is sine theta is equal to 90 degrees, sine 90 is equal to 1, v is equal to minus a omega. So that velocity is maximum which is equal to minus a omega. Clearly given about the mean position. Mean position is velocity maximum, that's why kinetic energy also maximum. Kinetic energy is equal to half m v square. Okay student, after velocity, okay, second case is there, that is extreme position. Then we will discuss about the acceleration. Wait, yes student, now continuation, their extreme position also we have to replace the values. For this extreme position, again two conditions are there, so that x is equal to plus or minus a, and theta is equal to 0 degrees or 180 degrees, 0 degrees or 180 degrees. See student, for this explanation, x is equal to plus or minus a, extreme position clearly represented in the diagram also. See student, x is equal plus or minus a, here along the positive x-axis plus a, along the negative x-axis minus a. Okay, yes, and the values replacing now in velocity equation. Velocity equation is v which is linear equation minus omega root over a square minus x square, a square minus x square, and here velocity which is equal to minus a omega sine omega t. Okay, both are replacing now. Continuation we will get here velocity v which is equal to minus omega root over a square minus a square. See there, a square is get cancelled, so that velocity is getting 0. So velocity is minimum which is equal to 0 at the extreme position, so that extreme position kinetic energy also equal to 0. And next going to discuss about the angular value velocity equation, v which is equal to minus a omega, this is sine 0 or sine 180, both are 0, so 0 into anything is equal to 0. So here also same situation, we are getting velocity is minimum at the extreme position. Two conditions clearly explaining. Okay, and then next acceleration equation, so that for acceleration the rate of change of velocity is called acceleration. See student, for this acceleration already we have the velocity equation here only clearly written. I will use this formula. Okay, and acceleration a is equal to dv by dt. Okay, rate of change of velocity is called acceleration, so that acceleration a which is equal to d by dt of velocity is minus a omega sine omega t. Okay student, and the value minus a omega t is common, so that acceleration a which is equal to minus a omega, so d by dt of sine omega t become cos omega t, and constant omega again common second time, second differentiation is completed, so that acceleration equation a is equal to minus a into omega is omega square cos omega t. This is I can write as equation number 3a, acceleration equation. In this equation we can replace from equation number 1, from equation 1, that is x is equal to a cos omega t. A cos omega t is replacing, so that I will get second equation for the acceleration. Wait a second. Yes, second equation for the acceleration. So acceleration a which is equal to minus omega square into this is a cos omega t become x. So written clearly x. See clearly student, a cos omega t is equal to x from equation 1. So this is I can write as equation number 3b equation. Okay, and from the simple harmonic motion, okay, from simple harmonic motion, that is a directly proportional to the minus x. See student, acceleration is directly proportional to the displacement in magnitude and opposite in direction. So we got the two equations for the acceleration, and mean position and extreme position cases also we are going to discuss. So that mean position, extreme position values are representing mean position x is equal to 0 and theta is equal to omega t which is equal to 90 degrees. Okay, and extreme position x is equal to plus or minus a writing, and theta is equal to omega t which is equal to 0 degrees or 180 degrees writing, 180 degrees. Okay student, and the values replaced in this acceleration equation. So acceleration equation also writing there, acceleration for linear a is equal to minus omega square x. Here a is equal to minus omega square x clearly from the 3b equation. And next here acceleration a which is equal to minus a omega square cos omega t, and A which is equal to minus A omega square cos omega t. So next, see student, acceleration A which is equal to minus omega square into 0, 0 into anything is 0, so acceleration is minimum at the mean position. Whenever acceleration is minimum, then potential energy also minimum at the mean position. So total energy in the form of kinetic energy only. And next one here, A which is equal to minus A omega square cos 90 is equal 0, 0 into anything is 0. Here also I am getting minimum acceleration in both conditions. Okay, x is equal 0 and theta is equal to 90 degrees. Okay student, and next one, acceleration A which is at the extreme position. Okay, so A is equal minus omega square, x value is replacing there, that is A writing there, so plus considering A which is maximum, that is maximum acceleration is equal to minus A omega square. Here acceleration is maximum, nothing but potential energy also maximum. Okay, and next one here, acceleration A is equal to minus A omega square cos 0, that is 1, cos 0 is equal 1, cos 180 is equal minus 1, plus or minus amplitudes we will get. See clearly, we have the graph also, velocity and time graph, and this is acceleration and time graph. Okay, so that acceleration A which is equal present 0 considering, okay, minus A omega square, that is equal to acceleration is maximum, that is minus A omega square. So again I don't want to write, already written there, potential energy also maximum. See student, if we take theta is equal 180, we will get cos 180 is equal minus 1, minus of minus plus. Here also we are getting plus A omega square and also minus A omega square. Acceleration and velocity also plus value and minus value both are represented. So that I wanted to represent now first one velocity graph and also next acceleration graph. After that I will discuss about the time period and equation of the simple harmonic motion student. Okay, see already given there, this is the reference circle in which the particle moving with angular velocity omega in anti-clockwise direction. This give the displacement equation, displacement and time graph. This is representing xt graph. Okay, and next I'm going to explain, this is on the x-axis is time and y-axis is velocity, so that this is the velocity time graph. Okay, so velocity time graph representing velocity conditions clearly given. At mean position velocity is maximum in both conditions, so mean position velocity is maximum, extreme position velocity is equal to minimum, so that representing there here clearly, so that mean position is velocity is equal to maximum student. So this is representing 0 time, this is the time representing t divided by 4, and this is the time is representing t divided by 2, and this is the time is representing 3t divided by 4, and this is total time period. Okay, and next I am going to write about the phase, 0 phase, and this is pi by 2, and this is pi, and this is 3 pi by 2, and this is representing 2 pi for one rotation. Okay student, see clearly represented phase and time period in velocity time graph. Okay, and see there, here velocity is maximum A omega, here velocity is maximum minus A omega, we got here velocity is maximum minus a omega. See there, because of the equation of velocity equation we are getting negative sign here. See, v is equal minus a omega sin omega t, v is equal minus omega. So that clearly represented graph. We started with negative velocity minus a omega, after that velocity get positive, that is plus a omega. Okay student, in this diagram representing on the x-axis is displacement and y-axis is velocity. Clearly along the x-axis y coordinates are 0, along the y-axis x coordinates are 0. So that along the x-axis here a representing positive, so that velocity is equal 0. And along the y-axis, so that velocity is maximum a omega, minus a omega there here. Okay, we got plus a omega and also minus a omega. In this condition x is equal to 0. Whenever velocity is maximum, displacement is equal to 0. So along the x-axis y coordinate 0, along the y-axis x coordinate 0, along the x-axis there is a displacement, that's why velocity is equal 0, along the y-axis velocity but displacement is equal to 0. Okay, and next one acceleration is there. For this acceleration, see here representing, this is time is equal 0, this is t divided by 2, this is t divided by first one t divided by 4, and this is t divided by 2, and this is 3t divided by 4, and this is t. Time taken to complete one rotation is called time period of the wave. And also next phase representing there, the phase which is equal to pi divided by 2, this is pi, and this is 3 pi by 2, and this is 2 pi representing. Yes student, now clearly about this acceleration and displacement, both are, see, a directly proportional to the minus x, so that graphs also quite opposite. Here graph for the displacement start from the plus a, and here acceleration I am getting the first acceleration is maximum, that is minus a omega square. So that graph start from acceleration is negative, displacement is positive. Next displacement is negative and here acceleration is positive, because of a is directly proportional to the minus x. Minus represent opposite. Displacement and acceleration graphs are quite opposite. And on the x-axis considering here displacement and y-axis considering is acceleration, so that here there is a slope represented. For this slope clearly we have to understand, so acceleration is a omega square and displacement is minus a, that is amplitude. Okay, and here also clearly represented, so that amplitude is plus a but acceleration is negative. Any one of the physical quantity is negative, so for this slope amplitude is negative, for this slope acceleration is negative. For this time period, first simple harmonic equation I am using from the equation 3b, that is a is equal to minus omega square x. Okay, so that a minus represent is opposite direction, so that a divided by x which is equal to omega square, see there, and omega which is equal to root over a divided by x clearly represented, but omega which is equal to 2 pi divided by t. Okay, so that continuation equation there, 2 pi by t which is equal to root over a divided by x. Okay, and cross multiplication 2 pi root over x divided by a, which is equal to t. Clearly we got time period t, which is equal to 2 pi root over x divided by a. Okay student, and then this is I am representing acceleration relation is 4, and this is equation number 5. Okay, and then next one is equation of simple harmonic motion. This is also from equation number 1. Okay, see there, that is a, which is equal to minus omega square x, so that acceleration a, which is equal to d square x divided by dt square, so that d square x divided by dt square, which is equal to minus omega square x, so that d square x divided by dt square plus omega square x, which is equal to 0. This is representing equation number 6. Equation 6 represent equation of simple harmonic motion. Okay student, and then continuation here representing position, mean position, extreme position, positive and negative. Here clearly represented mean position x is equal to 0, x is equal 0 and theta is equal to 90 degrees. See, x is equal to 0 and theta is equal to omega t, which is equal to 90 degrees. Okay, mean position, velocity is maximum. See there, velocity is maximum. Velocity is maximum. Vmax is equal minus a omega. So that whenever velocity is maximum, kinetic energy also maximum. And mean position, acceleration is minimum. See there, acceleration is minimum, mean position clearly represented. That's why potential energy also minimum. And extreme position, here x is equal plus a. See there, x is equal to plus or minus a. So theta is equal to 0 degrees or 180 degrees. So I can write here theta is equal to 0 degrees and here theta, which is equal to 180 degrees. See student. Okay, so that at extreme position velocity is minimum. See there, extreme position velocity is equal minimum. That's why kinetic energy also minimum. But extreme position clearly represented x is equal plus or minus a, so that acceleration is maximum minus a omega square. Here acceleration is maximum, that's why potential energy also maximum. Energy neither be created nor be destroyed, total energy is remains constant. At mean position, total energy in the form of kinetic energy, so that when the particle is moving from the mean position to extreme position, that kinetic energy convert into potential energy. Thank you. Please do like and subscribe our channel Nature of Physics.